Okay, in this lesson we talk about capacitance. It's unit 2 in the syllabus. What do you mean by capacitance? Consider an isolated sphere. This is a sphere, isolated sphere, connected to higher or high voltage supply. So if we connect this sphere to voltage, higher voltage, then we know that as the potential of the sphere as potential V increased, the charge stored on the sphere also increases. Then we have direct relation between Q and V. So we write the charge is proportional directly to the potential difference. If we draw the relation between the charge on y-axis and the potential difference on x-axis, we will get a straight line passes through the origin because it's a direct relation. Then we can write Q equals the constant multiply V. This constant denoted by C, where C is constant that depends on what? On the size and the shape of the conductor. C is known as capacitance of conductor. Now, what is the capacitance of conductor? It is the ratio of a charge to potential difference. It is the ratio of a charge to potential for conductor. So C equals Q over V. C is capacitance measured in farad. So the unit of capacitance is farad. Unit of a charge is coulomb. Unit of potential is volt. Then 1 farad equals 1 coulomb per volt. Then we have this important relation, C equals Q over V. Or we can draw this triangle, so Q equals CV, C equals Q over V, V equals Q over C. So remember, Q equals CV, CV, to be easier to remember. Capacitance measured in farad. Farad is big unit. We use microfarad instead of farad. 1 microfarad equals 10 power negative 6 farad. Definition of capacitance is important. Definition of farad also is important. What is farad? 1 farad is 1 coulomb per volt. Okay? Then, what is the capacitance? Capacitance of conductor is the ratio of a charge to the potential. We have important triangle. This triangle is important. Q equals C times V. C is capacitance measured in farad, denoted by F capital. Farad is big unit. We use microfarad instead of farad. 1 microfarad equals 10 power negative 6 farad. It's okay? Now, let us solve this example. Now, we read the example. The charge on a certain isolated conductor is, so this is Q, charge. So the given is Q, 2.5 multiply 10 power negative 2 coulomb. When its potential is 25 volt, so the potential V is 25 volt. Calculate its capacitance, C. Remember the formula. The formula is that the triangle Q equals C times V. What do we need? We need C, capacitance. So C equals Q over V. We do substitution. So Q equals 2.5 times 10 power negative 2 coulomb over 25. we use the calculator to get the answer. Fraction 2.5 multiply 10 to the power negative 2 divided by 25. So the answer is 1 times the 10 power negative 3. So the answer is 1.0 multiply 10 power negative 3. Remember, the capacitance measured in farad, capital letter. Okay? Now, try to solve this question, please. Let us we solve it together. Calculate the charge. Then the required is Q. Calculate charge. Then we need Q. So this is the required. Stored in an isolated conductor of capacitance. So this is C, capacitance. It's 470 microfarad. When the potential difference is 20 volt. I advise you to convert it to farad. We can solve with microfarad and the answer it will be microcoulomb. But I advise you to don't confuse, convert it to farad. We said that 1 microfarad, if you remember, 1 microfarad equals 10 power negative 6 farad. 1 microfarad, here, 1 microfarad, it's 10 power negative 6 farad. Then I advise you to convert it to farad to be in safe. Then we convert it to farad. So it's 470 multiply 10 power negative 6 to be in farad. When the potential is 25 volt, V equals, 20 volt. Now, what is the formula? Remember, Q equals CV. What do we need? We need Q. Then Q equals C multiply V. C is the capacitance, which is 470 multiply 10 to the power negative 6 multiply 20. Now, we use the calculator to get the answer. 470 multiply 10 to the power negative 6 multiply 20. So the answer is 9.4 multiply 10 to the power negative 3, the charge measured in coulomb. Take care the unit of a charge and the symbol of capacitance. Take care, okay? So, okay. Now, let us, we talk about the next part, capacitor. We talked about capacitance. Capacitance, this is for any conductor. But now we talk about the capacitor. What is the capacitor? Capacitor is the device that consists of two conductors, two metal plates that are closed together but are insulated from one another by isolated material like wax or paper or air called dielectric. Now, what is the capacitor? This is the capacitor. It is an instrument used to store and release electrical energy. نستخدمها في تخزين electrical energy. So الكاباسيتور هي instrument بنستخدمها في ايه؟ To store and release electrical energy. زي مثلا الباور بانك اللي بنشحن بيه الموبايل ده بيبقى فيه capacitors. يبقى الكاباسيتور is device that consists of two conductors, two metal plates that are closed together but are insulated from one another. Now, capacitor does not store a charge but store energy. Now I explain what do you mean by this. How can we store energy? To charge the capacitor, we connect the plates of capacitor to a cell or battery. Now, what will happen? The electron transfer from the negative pole of the battery to one plate. That electrons repel the electrons in the opposite plate because the two plates are close to each other. Then the electrons in the opposite plate will be repelled and then go directly to what? To the positive pole of the battery. Now, when the electron moves toward the positive pole of the battery, leaving behind positive charge on one plate. On the opposite plate, already we have electron, then it contains a negative charge. Then we have two types of charge. They are equal but opposite. Then the total charge is zero. For example, if the charge on one plate is negative 5 coulomb and the charge on the opposite plate is positive 5 coulomb, negative 5 plus positive 5 equals 0. So the total charge is 0. Then the capacitor does not store a charge. But to separate the positive charge away to the negative charge, work is done. This work done stores as electrical energy. Then the capacitor stores electrical energy. So remember, the capacitor does not store a charge because the total charge is 0. Why? Because the charge on one plate is positive, on the opposite plate is negative, the same value but different sign, then the total charge is 0. But to separate the positive charge away to the negative charge, work done to separate the positive away to negative. This work done stores as energy. So the capacitor stores electrical energy but does not store charge. Now, this is the definition of capacitance. What is the capacitance? This definition is important. If we said define the capacitance of capacitor. So this definition of what? Capacitance of capacitor is the charge stored on one plate per unit potential difference between the plates. Not, we don't say the charge on, no, charge stored on one plate because the total charge is here. Okay, now let us we do this example. Of course, we use the same formula. Q equals C times V. Now, here, try to solve this example and then we solve it together after you finish. Try. Now, let us read the question to check your answer. When capacitor is charged from 12 volt, then this is the voltage, 12 volt, 6 microcoulomb. Microcoulomb is a charge. It is unit of a charge. Then Q equals 6 microcoulomb. I advise you to convert it to coulomb. Micro 10 power negative 6 to be in coulomb. What is the capacitance? Capacitance denoted by C. Then the capacitance equals Q over V. So capacitance capacitance C equals Q over V. We do substitution. Q equals 6 multiply 10 power negative 6 divided by 12. By the way, if you leave Q in microcoulomb, the answer will be in microfarad. But I advise you to convert. It's better to be in safe side. 6 multiplied by 10 to the power of negative 6 divided by 12. So the answer is 5 times 10 power negative 7. This is the capacitance in farad. 5 multiplied 10 power negative 7. The unit is farad. Okay, you got it? Now, let's try to solve this please question. Try. Check your answer with me. We read the question and then we write the given. Calculate the charge. Then the required is Q. On 220 microfarad capacitor. Then we have the capacitance C. 220 microfarad. charged up to 15 volt. V equals 15 volt. Give your answer in microcoulomb. Okay. So we leave the capacitance in microfarad. Now, what is the formula? Remember the triangle Q equals C times V. So Q equals C times V. We do substitution. So capacitance, when the capacitance in microfarad, the charge will be in microcoulomb. 220 microfarad multiply 15. Now, we don't convert because we need the answer in microcoulomb. So 220 multiplied by 15. The answer is 3.3 multiplied by 10 to the power 3 microcoulomb. Now, try to solve next question. First of all, we read the question. Some computer chips use capacitor to provide energy for a short time. If there is a power failure, a 100 microfarad capacitor, then we have here capacitance. So C equals 100 microfarad. I advise you to convert it to farad. Then it's 100. Okay, so it's 100 multiply 10 to the power negative 6 farad. Okay, to 9 volt, then the voltage is 9 volt. What is the charge on the capacitance? We need Q. Part B, how long? We need the time. Okay, how long it be able to supply a steady current of? Then here we have the current in microampere. I advise you to convert, by the way, to be in safe side. Then the current is 50 microampere. We convert it to ampere, 10 to the power negative 6 ampere. Let us resolve part A. Now, part A, Q equals C times V. C is the capacitance, 100 multiply 10 to the power negative 6 multiply 9. So the answer is, okay, 100 multiply 10 to the power of negative 6 multiply 9. So the answer is 9 multiply 10 power negative 2. We don't need the calculator to solve, but to be in safe also. Negative 4, and the unit of a charge is coulomb. How long? We need the time. Now, which formula for the time? Q, now what is Q equals what? Equals I times T. This is from unit 1. Then the time from unit 1 equals Q over I. Q is the charge in coulomb. The charge is 9 multiply 10 power negative 4. I is the current in ampere, 50 multiply 10 power negative 6. Now the answer in the calculator divided by open bracket. 50 multiply 10 to the power of negative 6, close the bracket equal, it's 18 seconds. So the answer is 18 seconds. In my calculator, it's 1.8 times the 10 power 1. But if the power is 1, we have to convert to 2 norm. So it's 18 seconds. Okay? Now let us go to the next part. Combinations of capacitors. It's like resistors, but it is opposite. In resistors in parallel, if you remember, so R total is 1 over R1 plus, but here it is opposite. In parallel, the charge is more. So if we need to increase the capacitance of capacitors, we connect them in parallel. And this is C total. It is the sum. So remember, capacitors in parallel, they have the same voltage, but different charges. Same voltage, but different charges. So remember this. So capacitors in parallel, to increase the capacitance of capacitors in parallel, to increase the capacitance of capacitors, we connect them in parallel. Okay? In parallel, the voltage will be the same, but the charge will be different. And the C total is the sum. It is opposite to resistor, if you remember. Okay? Resistors in series, this is like parallel in capacitors. Now, try to solve this example, my friend, as we check. Okay, we read the question. Calculate the total capacitance. We need C total of it means 200 microfarad capacitors connected in parallel. Here we don't convert to farad. I advise you to be easier. Then we write, because it is in parallel, so C total equals C1 plus C2. There are two capacitors, 100 plus 100 equals 200 microfarad. This is the total capacitance of the two capacitors in microfarad. Calculate the total charge they store when charged to. Now, in part B, we have the total voltage. V total is 20. What do we need? We need Q. What is Q? Q equals C times V. Of course, C total and V total. C total is 200 microfarad. Now, it's a good idea to convert to farad. So it's 200 multiply 10 power negative 6 to be in farad. Multiply the voltage, it's 20. Then we can get the answer. So 200 multiply 10 to the power negative 6 multiply by 20. So the answer is 4 multiply by 10 to the power negative 3. The unit is coulomb. Okay? Okay. Now, capacitors in series. Now, in capacitors in series, they have the same charge because the same current. So remember the same charge, but what? Different voltage. Different voltage. And here, capacitors in series, the capacitance will be less. C total equals 1 over C1. It's like parallel resistors, like parallel resistors, like parallel resistors. Okay, now remember please, here, capacitors in parallel, capacitors in series. In parallel, same what? Same voltage. Same voltage. In series, same charge. And C total in parallel, C1 plus C2 plus C3. In series, C total equals 1 over C1 plus 1 over C2 plus 1 over C3, all to the power negative 1. To increase the capacitance, we connect the capacitors in parallel. To decrease the capacitance, connect them in series. Okay, so remember that. Now, we solve this example. Try to solve this example. Okay. Okay, we solve it together. Okay, first we read it. Calculate the total capacitance. We need C total of 3 capacitors of capacitance connected in series. Series. So C total, this is the formula, equals 1 over C1 plus 1 over C2 plus 1 over C3 all to the power negative 1. It's like like parallel resistors. Then C total equal, don't convert to farad, because just we need the total capacitance. So it's 1 over 200 plus 1 over 300 plus 1 over 600 all to the power negative 1. Now we use the calculator, bracket, fraction, 1 over 200 plus fraction 1 over 300 plus fraction 1 over 600, close the bracket, all power negative 1. The answer is 100. 100 what? Microfarad. So the answer is 100 microfarad. Note that the total capacitance is less than the smallest capacitor. Look, the smallest capacitance is 200, but here the total capacitance is 100. So the total capacitance in series is less than the capacitance of the smaller capacitor or the smallest capacitor. Okay. Now, if we have many combinations like this, we have to calculate the parallel like this and then to combine them like this if they are more complicated to find the equivalent capacitance. Okay. Now let us talk about the energy stored in capacitor. Look, my friend, here we have V and Q. So remember, if it's V multiply Q, the relation, of course, is a straight line because we know that Q proportional directly to V. So the capacitance is 1 over the slope because it is not QV, it's VQ. This is the capacitance. But what is the area under the graph? The area under the graph is the energy stored in the capacitor. The energy, because it is triangle, so it's a half base times height. The base is Q and the height is V, then it's a half Q times V. Remember, the energy of any other instrument like resistor, lamp, motor, anything, QV. But the energy of capacitor is half QV, not direct QV. And because we have the formula Q equals CV, we can replace Q by its value. Then we have 3 formulae for energy. Half QV or half CV squared or half Q squared over V, or Q squared over C. Which formula we use it depends on the given. Then the main formula is half QV. And you can put beside it Q equals C times V to do substitution. But all the formulae will be in the formula sheet. Now, let us resolve this question. Look, my friend, here he said, we write the given here. Okay, 2000 microfarad. Then the given is the capacitance, microfarad. So C is given 2000 microfarad. Okay, I advise you to convert to farad because it is not connection. So it's 2000 multiply 10 power negative 6 to be in farad. To be in safe, use your calculator. 2000 multiply 10 to the power of negative 6. So the answer is 2 multiply 10 power negative 3. 2 multiply 10 power negative 3 farad. This is the capacitance. Is it charged to 10 volt? Then the voltage is 10 volt. Calculate the energy. We need the energy. Sometimes we write W or E. Both are correct. Now we have C and V. So which formula? Half CV squared. Formula number 2. Then we write the energy equals a half, because we have already C and we have V, half CV squared. Of course, remember the energy measured in joule. So it's a half multiply. C is the capacitance. It's 2 multiply 10 power negative 3. Multiply open bracket. V is 10, so it's a 10 squared. Now, we write half multiply by 2 multiply by 10 to the power of negative 3 multiply by 10 squared. So the answer is 0.1. 0.1 what? Joule. This is the energy stored. Now, try to solve this example. I will move it down. Okay. Try to solve this question, please. Okay, try to solve. By the way, remember milli, micro, nano, pico. Okay, if you forgot it, milli, micro, nano, pico. Milli, it's a 10 power negative 3. Micro, 10 power negative 6. Nano, 10 power negative 9. Pico, 10 power negative 12. Milli, micro, nano, pico. Milli, micro, nano, pico. So, picofarad to convert to farad, multiply by 10 power negative 12 to be in farad. Now, try to solve this example. First, we have to write the given. Dam of Van de Graaff generator has capacitance, this is C, it's 20 picofarad. So from picofarad to farad, I said multiply 10 power negative 12. So it's 20 multiply 10 power negative 12 to be in farad. Calculate the energy. So we need W. Is raised to a potential. So this is V, but it is in kilovolt. We convert to volt. Kilovolt, it's multiply 10 power 3. Now we have C and V. Which formula we use it? Let us return back. Yes, the second formula, because we have C and V. So half CV squared. Then we write the formula. The formula is that the energy equals half CV squared. Now, half multiply C equals 20 multiply 10 power negative 12. Open bracket, it's better. So 100 multiply 10 power 3, of course, it's 10 power 5 is squared. Now we find this answer. So it's half 0.5 multiply 20 multiply 10 to the power negative 12 multiply bracket 100 multiply 10 to the power of 3 all squared. Then the answer is 0.1. So the answer is 0.1 what? Joule. Now, try to solve this example, please. Or I solve with you because the time. Capacitor is charged using a steady current. We have I. Now, the given is I, but it's 20 microampere. We have to convert it to ampere. 10 power negative 6 to be in ampere. From 5 volt supply, V equals 5 volt. After 5 seconds, this is the time, 5 seconds, is fully charged. Calculate the charge. Oh, we need Q. What is the formula that we use? Q equals I multiplied by T. This formula from unit 1. So Q equals I it's 20 multiply 10 power negative 6 multiply 5. Then the answer is, use the calculator, to 20 multiply 10 to the power of negative 6 multiply by 5. So the answer is 1 times 10 power negative 4 coulomb. 1 times 10 power negative 4 coulomb. Now we solve it part A. Calculate the charge. Now, second part, it's capacitance. We need C. Oh, then we have the formula Q equals CV. So C equals Q over V. Q is 1 multiply 10 power negative 4 divided by V. V is 5. So the answer divided by 5. So the answer is 2 times 10 power negative 5, the capacitance in farad. The energy stored. Now we need the energy. Which formula we use it for energy? Let us see. Okay, just move this down. So part C, we need the energy. Already we have V is given and the Q we calculated. Then which formula? Half what? We have Q and V, half QV, the first formula. Because we have Q, then it's a half, sorry, it's a half QV. Half multiply. Q is the charge, which is 1, multiply 10 power negative 4, multiply V, multiply 5. Then half multiply by 1, multiply 10 to the power of negative 4, multiply by 5. So the answer is 2.5 times 10 power negative 4. 2.5. Oh, yeah. Mouse music. Okay, sorry. So the answer here is 2.5 times 10 power negative 4 and the unit is joule. Again, the answer is 2.5 times 10 to the power negative 4 joule. This is the energy stored now. Okay, now. Okay, try to solve this question, please. Try to solve this. Okay. Yeah. First of all, we write the given here. Camera flash lamp uses 5,000 microfarad. So this is the capacitance. 5,000 microfarad to farad, 10 power negative 6 to be in farad, which is charged by 9 volt. Then the voltage here is 9 volt. Calculate the energy when the capacitor is fully charged. Then half CV squared. The energy is half CV squared. Remember the formula. The energy is what here? Half CV squared, number 2. Then we write the answer here. So the energy equals half CV squared. It's half multiply. C is 5,000 multiply bracket 9 squared. Now we can get the answer. Yeah. Half multiply by 5,000 multiply by 9 squared. So the answer is 2.03 multiply 10 to the power 5 and the unit is joule. Now I will give you this, try by yourself. Okay, I will give you the homework. Then this question will be a homework for you. Okay, I hope you understand this lesson.